do you remember what this graph looks like from class or from our work?
It will look like it's from 0.
There's a specific letter of the alphabet that's often used for this.
It's X.
So let me graph it. What letter does this look like? What letter in the alphabet does this graph look like?
A V.
It's a V shaped, yeah. Okay, so this point right here at the bottom is called the vertex.
Yeah.
Okay, so that's what moves the graph around. If the vertex changes, then the equation changes also. So let's do this. Let me
Yeah, and also the set notations and different notation.
okay. So let's look at a new function. Let's say it's y equals the absolute value of x minus 2.
Okay.
Okay, so this shifts the graph over here to the right.
Okay.
But do you see how this number is negative, but yet it shifts right?
Mm-hmm.
Does that feel like opposite or backwards to you?
It's like opposite. It's like backwards to me.
Yeah.
Yeah, I would say that.
Okay. So notice now if I graph something like this, y equals absolute value x plus 3, what do you think is going to happen here? Which way is it going to shift the graph?
Which way is going to shift the graph?
Yeah.
That right there, it's going to
Minus
be
2 shifted it right. So what do you think plus 3 will do?
go to the left.
It's going to go left 3. It shifts it left.
Mm-hmm. Yeah.
So now the graph of this again, like you just saw there. Actually, let me do a little better job here. Let me graph it kind of the same here. It shifts it left 3, so it looks like this. Okay. Now in this top graph, the vertex is at 2, 0. The vertex here is at minus 3, 0. Okay.
Yeah.
So now let's look at a problem that's really similar. So let's say it's y equals absolute value x minus 2 plus 1. So here is the new vertex. The vertex is right 2, but now up 1. Why did the vertex go up 1 this time? What caused it to go up 1?
It goes up because no, for x minus 2, you just have to go at the right to increase to up.
Well, the 2 right is from this. This is the right 2. So what causes the up 1?
The up one, the up one will be going left 1.
What in this equation right here that I'm circling, if you're seeing my screen? What
Y
in this
equals what the x minus 2 plus 1.
so what causes it to go up 1? What is the other number in this equation that I'm not using, that I
X
haven't
minus
circled?
2.
That's the right 2. So what causes it to go up 1? What else do you see in the equation?
Positive 1.
So that's what causes it to go up 1.
Yeah.
That's what changes this number. The right 2 changes this number.
Okay.
Is that okay, or is that still
Yep, that's
unclear?
clear. That's clear.
Okay. Now in the previous problem, I wrote y equals absolute value x plus 3. Which direction did this move things?
Okay, the direction that goes
Yes,
at the left.
left 3.
Mhm.
Now watch this. So I'm going to graph this. And here's the vertex. Do you see that it went down 1? This right here causes it to go left 3.
Yeah. And for -1, it goes down.
That causes it to go down 1. Okay. So now I'm going to give you a new problem, and you need to tell me what's going to happen here. So let's say y equals absolute value x minus 3 plus 2. I need to know left or right, up or down, and then how much for each one.
Okay.
Be right back, Sourish.
Okay.
Okay, Sourish, how are you doing on this one?
I know what it is. It's
Okay.
right. It's right 3 and up 2.
Up to good. Okay, so let's try another one here. Okay, could you try this one, please?
Yeah. Left 2, down 5. Left 2, down 5.
Left 2, down 5. Perfect. All right, very good. So does this graph open up or down? Do you remember that? And that has to do with the number right here. What number is right there but not written?
Okay, what so wait, what?
I'm asking you, does this open up or down?
It opens down.
Like, go ahead, let's go back and look. Let's go back and look. Which way do these graphs open? Up or down?
Okay, it goes up
Goes up. Now, why is that?
because 3 goes 11 and 0 goes up.
Okay.
Yeah. That's what it does.
All right.
Yeah, zero can make can make the line go up into the certain average distance right there, and that's what it does, Matthew.
Great. Okay, so are these different than the problems that you're having in your exam? Because you seem like you understand them.
Yeah, yeah, I understand them. -5, it goes down.
No, I know, but what were you getting on your test? Like, what's the different?
I just got it right. Can you want to scroll up?
Yeah, but what kind of problems do you think you're going to see on your test? Because that's what I'm asking you to like. Are they like this or are they something else?
They're like something else. It's like absolute value for set notations, and it's a very big problems, like tough challenge problems.
Could you write one down on a piece of paper, even if it's not the same numbers, just to show me what you mean? Like maybe what you remember from class.
I don't even know what does it look like. I forgot because I was doing my test. Or
Well, you
maybe,
must remember. I mean, you
or maybe let me just try.
okay.
Can I share my screen?
Uh, well, you can turn on your camera or you can take a picture and send it over to me, whatever is easiest for you.
I just wanted to share my screen so I can show it to you.
Is it so it's on your screen? I can make you host. Is that what you would like to share your screen?
Yeah, I should share my
All right,
screen and you can be
let
able
me
to see.
all right, let me make you host, co-host. All right, whenever you're ready, go ahead and share your screen.
Which is this is for what you need to see, Matthew. It's like this.
Okay, yeah, these are called quadratic inequalities.
Yeah.
Yeah. Okay, so this would have been perfect to send over to me in preparation for our session today. So yeah, let me grab this question and I'll share my screen and we'll work through this one and then some like it.
Number A.
Yeah,
Yeah, this is like this, and then but then I just the teacher was just helping us out of what does it do and how are we supposed to do it, but I just don't even remember. I just follow the teacher's instruction just to write it. I just still do not know.
sure. So it says solve the inequality by factoring. Okay. So the very first type of factoring you're always supposed to do is what's called GCF factoring, greatest common factor. We have done that.
Oh yeah.
And it's in this case, it's a number. Do you see that everything is divisible by 2?
Yeah.
So you're literally dividing everything by number 2. So that becomes x squared minus 6x plus 5.
Okay. So can I write these down?
Sure. If you think that'll help, I would write it down.
Okay.
So
All
the
right.
next step is you need to find two numbers that multiply to 5, but add to -6. So they have to multiply to this 5 over here on the right, but add to -6 here on the left. Can you think about what numbers those might be?
1 and 5 can multiply to 5.
That's true, but does that add to -6?
Add -6. No.
But we're close, right? It's 6. We want
Yeah.
-6. So how should we change each of these numbers?
I think we have to put like one positive and one negative.
They're actually both negative.
Actually, both negative. Oh, wait. Oh, yeah. Oh, wait a minute. Wait, negative 1 times -5 is -6.
No, -1 times -5 is 5. -1 plus -5 is -6.
Okay. Okay.
So now you write x minus 1, x minus 5, and you set each of these equal to 0.
Yeah.
So what are the two x values?
Two x values. The two x values are 1 and are the two x values are 1 and 5.
Yes, x is 1 and x is 5. Now, what we have to do next is remember that what the graph of this looks like. The graph of this is, actually, that's not a good place to graph it. Let's graph it here. It hits at 1, 2, 3, 4, 5. Okay, and see how it crosses? The graph looks like this. So
Okay.
remember 2 days ago, we were talking about what this symbol right there is. This means less than.
Yeah.
So less than means below the x-axis. So do you see that this part down here is below the x-axis?
Yeah. It was less than because they were both less than to beneath the x axis.
Yes. So see how it's below between in this area right here,
Yeah.
which is between 1 and 5.
Yeah.
So we would say 1 less than x less than 5.
Uh-huh. Okay.
So now, did you also have to do this in
What?
interval notation or just this notation?
The set notation
Just this
and
notation, or
integral
did you also have to
notation.
do this? Okay, so this is interval and this is set.
Okay. So wait. So internal,
Interval.
so interval is the coordinates and the set is like, what is it
Inequality.
about?
It's got the set is this inequality stuff.
Okay. 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 I got it down.
Okay, so let's do another problem. Give me just a moment here to get this set up for you. All right, so we're gonna go 3x squared plus 15x minus 18 less than 0.
Okay.
So the first thing to do when you see a problem like this is GCF factoring. What number goes into all three of these? What number divides each of those?
What number divides each of those?
Yes, what number perfectly divides each of those?
3.
3. So you put a 3 on the outside, but you're dividing each of these by 3. So it's x squared plus 5x minus 6.
Yeah.
So now you need to find two numbers that multiply to minus 6, but add to 5.
Would add to 5. Okay.
So take 30 seconds and see if you can figure that out, please.
Yeah.
All right, do you have those two numbers that multiply to minus 6 but add to 5?
I'm still doing it. I
Okay.
have to just get caught. I
All
have to
right,
get caught up.
take your time, take your time.
Okay, -3 plus 2. Yeah.
You said -3 and +2, is that right?
Yeah.
Okay.
I
Those
said plus
definitely
because that is going to be adding to 5.
well, those definitely add multiply to minus 6, but -3 plus 2 is -1.
Oh,
So let's try a different set here.
okay. All right.
So any other ideas?
Okay, so multiply to -6, you have to multiply -6.
Well, you've got to find two numbers. Like these were fine, these work, but there's more than two numbers that multiply to -6.
All right, I got -1 plus -1 and 6.
Yeah, so -1 and 6, those do add to 5.
Yeah.
Good. Okay, so this becomes 3x minus 1, x plus 6 less than 0. So you have to set each of these equal to 0. So x minus 1 equals 0, x plus 6 equals 0.
Yeah.
Can you tell me the X values?
Yep. 1 and 6.
It is not 6. It is 1. I'll go with that.
-6.
Very good. Okay. So now what your graph looks like is here's 1, 1, 2, 3, 4, 5, 6. Here's -6. Your graph looks something like this. And we want where it's less than 0.
Okay.
Where is it less than 0? Where is it below the x-axis?
Okay, and it's from below, it's less than 0. It's less than 0.
Well, that's what we're looking for. Where is the graph below the x-axis? Between what two numbers?
Between what two numbers?
Yes.
Five.
What is the left number here?
-6.
And what is the right number here?
-1.
Positive 1.
Positive 1.
So is it below the x-axis between those two numbers?
Yes.
Yes. Okay, so that is -6 less than x less than 1. And that's set notation. We'll keep it simple. And then the interval notation is just the two numbers there.
Yeah. Okay. Got it down.
All right, so let's look at another problem here. Let's go. Actually, I gotta write this one out. All right, so -5x squared plus 10x plus 40 greater than 0.
Okay.
That symbol means greater than.
Yeah.
So I want you to first determine what number divides each of these.
Divides each of those.
Yes, what number goes into each of those?
5.
So we actually do -5 when it's like this. And the reason is because that first one is negative. So if you see like a negative out in front, make the number negative. So can you tell me what goes inside the parentheses, please?
Okay. Right there, it's x squared
Squared, good.
plus oh my -2. -2.
Minus 2x.
Yeah. plus minus 2x minus 8.
Minus 8, perfect. Okay. All right, so now you have to find two numbers that multiply to minus 8, but they add to minus 2.
Okay. Okay.
So can you tell me those two numbers, please?
Yeah. -4 and 2.
-4 and +2, those absolutely are the right numbers. This is x minus 4, x plus 2, greater than 0. So when you have a greater than, you want the above the x-axis. Okay, now this graph, it's a little bit, actually, we need to set them each equal to 0. So what is x minus 4 equal to 0? X plus 2 equals 0. What are the two x values?
X equals 4 and x equals -2.
Good. So here we go. Here's -2 and here's +4. But this time, do you see how there's a negative out in front?
Yeah.
That means it opens down. So it actually looks like this.
Okay.
So where is it greater than 0? Where is it above the x-axis? Between what two numbers?
Between what two numbers?
Yes.
-2 and +2 and 4.
+2 is right here.
Yeah. Okay. -2 and 4.
-2 less than x less than 4. And in interval notation, it would be -2, comma 4.
Okay. So that is how the inequality works.
Yes.
Okay.
All right. Let's try another one.
Okay.
Say y, I'm sorry, let's do it this way. Minus x squared plus 3x plus 4 greater than 0. So this time, do you see how there's a negative out in front?
Yeah.
You have to factor that out. You have to divide everything by -1.
Okay.
So can you tell me what would go inside parentheses?
Okay. X squared -3x
Yep. Last one.
-4.
Good. So now you need two numbers that multiply to -4, but add to -3.
Okay.
So I'm going to give you a moment to figure that out. I'll be right back.
Okay.
All right, Sourish, how are you doing on that?
I'm doing good. I'm doing good. All right. -4 and 1.
I agree. Those add to -3, so it's x minus 4, x plus 1. Now we have to set each of those equal to 0. So what are the x values here?
All right, right there. X equals 4. X equals -1.
Good. So does this graph open up or down? And it depends on this number out in front. Does it open up or down? It's a negative out in front.
It's down.
It's down. So we draw a graph where it hits at -1, 1, 2, 3, 4. And so we draw something like that. And we want greater than 0. So above the x-axis. Where is it above the x-axis?
And at the it's above next to -1 and 4.
So between what two numbers?
-1 and 4. -1 and 4.
-1 and 4. And in interval notation, it would look something like this.
Okay.
All right. Is there any other types of problems you would like us to look at tonight?
Any types of problems you want us? Any
Yeah.
types of problems?
Do you have any, like you have a test tomorrow? Do you have anything you want us to cover?
I already. I'm almost done with the test. We are just going to be finishing the test tomorrow. I'm almost done. We're almost done with it.
Okay. Do you have any questions for me to help you on that test? I'm asking if you want to stop here or if there's more that you want to do.
Well, there is what I just can't. Oh, there it is. Okay. What?
Do you want
Okay.
me to have? Do you want me to have you share your screen again?
I think that's
co-host,
all. I think that's. Oh yeah. Let me share my screen again.
Okay, you are co-host. You can do that at any time.
Okay, I think we have these right here.
Yeah, these, I mean, these are a little bit different. Do you want us to go through any of these?
Is there time?
It's up to you. Maybe letter C.
Let's do A. Well, come on,
A.
let's do all of them.
We don't have time for all of them. I would have needed to see this at the beginning.
Maybe we can do this on Tuesday if that's what you want.
Well, we can start letter A. Would you like to do that?
Yeah.
All right, let me share my screen.
Can I stop my share?
Yeah, I'm going to share my screen. You'll start seeing it. Okay, so it says extract the root. Extract the root. This one's a little bit odd because there's actually many different ways to solve it. How do I want you to do it? Well, so we're going to first assume that this is a equal sign.
Mm-hmm.
And we're just going to solve for x.
Okay.
So first thing you do is you're going to add 25 to both sides. That gives you x minus 2 squared equals 25.
Okay.
Now,
So you
if
have
you
to add to both sides by 25.
yes. Now, if you take a square root of both sides, you get x minus 2 equals plus or minus 5.
Okay.
And this is really two equations. It's x minus 2 equals 5, x minus 2 equals minus 5.
Okay.
So what are the two solutions here? What does x equal? What does x equal?
X equal. Can you go back? I have to. Okay, maybe. Yeah, go back up. Okay. Okay, so two solutions. That is going to be 2 and oh wait, negative 5. Wait, am I right?
You have to add 2 to both sides.
At 2.
Can you give me the value here?
The value there, that is going to be negative 2. 2.
Nope. What does this say? 5.
5 plus 2. It's 7.
Okay. How about over here? Negative 5 plus 2.
Negative 7.
No. Try again.
Three.
It is not 3.
Negative 3.
Yep. Okay. So if we were to graph those, there's negative 3, there's positive 7. Does this thing open up or down? It actually
I'll say
opens
up.
It actually opens up. So because we're running out of time here, I guess I'll have to kind of fill in a few of these, but it's because it's greater than 0, that's the area above the x-axis.
Uh-huh.
So that's x less than negative 3, x greater than 7. And then in interval notation, it's minus infinity minus 3 union 7 to infinity. So go ahead and get all that down. That does probably take us to the end of our lesson, but go ahead and get all that down and
Okay.
let me know when you're done.
Okay, I got that down.
Great. Why don't you let your dad know we're all done for today?
All right. Okay, Dad.
Yeah.
Well, thank you for some of the problems, Matthew.
You're welcome. We could have done it all. Just send it over ahead of time.
Hello, hi.
Hi, Dr. Guthrie. So tonight we worked on absolute value transformations. We also worked on solving quadratic inequalities. He showed me something about halfway through the lesson that if he would have sent over at the beginning, it would have helped to do those types of problems. So he's always welcome to send those to me ahead of time. Really, anything that he gives me from class is gonna be much better than me just sort of guessing what he means by stuff. So I guess he's got a test tomorrow to finish up. He did part of it today, so
Okay.
he should be in good shape for that.
So is he prepared for that? You think he can do it?
Yeah.
I think it's just...
Yeah, he's doing okay.
All right.
He does seem to understand we worked through the problem. So
Okay.
how does next week look for you guys? Do you want to schedule for Tuesday, Thursday? What do
Yeah,
you...
yeah. We will continue Tuesday and Saturday.
Sounds good. I will
Okay.
put it on the schedule.
Yeah.
All
thank
right.
you.
Thanks so much. I'll see you guys next week.
Yeah. See
All
you.
right.
Bye, Sourish.
Bye.
Have a great weekend. Bye.
Yep.